All right, we're going to do a lecture here on plotting points on a lathe. The lathe parts are round, right? So X is diameter and Z is length. Now, I have a part, and I have an side view, and I have an end view. Now, side view says it's a 0.875 diameter by 0.75 long. So I'm not going to worry about the center line of the part. I'm going to just plot the points on the outside. So the first point is A. Now the part is 875 diameter. On a lathe, you plot points the same way as you measure it. You measure all the way across. So for A, X is 0.875, Z is 0. For B, the diameter doesn't change, it stays 875. The length is 0.75 long. And since we moved to the left of 0, it's negative. So there's your 2 points. Now, next thing we're going to do is we're going to put a 45-degree chamfer. You notice I just drew the 45 across. These legs didn't change. I'm going to erase them because we would machine them away. I'm going to move the A down. I'm going to add B. I'm going to change this to C. So there's the 3 points. So A, well, left to right, that's still 0. What about diameter? Well, I don't have a notation here, so I'm going to just draw one in. How about 0.1 by 45? So from here to here is 0.1 inch. From here to here is 0.1 inch. So A is the full diameter of 875 minus 0.1 minus 0.1. Because we're seeing this twice. We're seeing it here, we're seeing it here. 0.875 minus 0.1 minus 0.1. .675. Now B, I went to the full diameter and I moved in 0.1 inch. So full diameter is 875. I moved in 0.1 negative. And I can even double check myself. 0.675 plus 0.1 is 0.775 plus 0.1 is 875. The next point, C, still 875. Z is negative 0.75. See how this is pretty similar to the last one? We just added this chamfering. This would behave exactly the same if it was a radius instead of a 45-degree chamfer. Now, if the chamfer is other than 45, they have to list all the dimensions. We'll cover that in a later lecture. Now, what if we added a shoulder? Okay, D and E. None of these changed, but we added D. Okay, D, X, 1.0. Length, well, we went straight up. It didn't move left to right at all, so Z is 0.75. E, we move down. Is that correct? 1 inch diameter, 1 inch diameter, 1.25, 1.25. So there you go, guys. That's how you plot a part. Okay, we're going to plot a different part here. I have a 1 inch diameter part. It's 0.5 inches from the end of the part to the top of the chamfer. The chamfer is 0.08 by 45 degrees. So what is point A? Now, if it's 1 inch diameter and the chamfer is 0.08, for diameter, we're going to measure that twice, or we're going to see it twice. So what is 1 inch minus 0.08? That would be 0.16, 1.9, 0.0, so 0.84. 0.84. What is Z? Well, face of the part, it's pretty much always 0. Now you notice X comes before Z. That's convention on programming. Now, that's A. So this length here, what do we got for B? Well, we got 1 inch diameter, and we moved over from 0 to 0.08. That's negative. Now next, we have to move down to C, the full length of the part. So we're going to add 0.5 and 0.08. 0.58, full diameter, and 0.0. So there's another part. Okay, I took the same part as last time, but I changed it to a radius. I used the same value. I just took the chamfers off and put a radius in. Now remember, on a radius, I have a center point, and I have part of a circle. It's the same distance from the center to anywhere on that circle. Think of it as a dog on a chain. The dog's got a 6-foot chain. The dog can run in a circle and cut a swath from the grass that's 6 feet from the center to the edge. It does 360 degrees, you add it together, it's 12-foot diameter, 6-foot radius, right? Okay, so got the same thing going on here, right? Okay, so we got 0.08 radius. A, Z is 0, it's the face of the part, and it's 1 inch minus 0.08 minus 0.08. Because remember, we're taking 0.8 off here and 0.8 off here, right? If you think of it this way, as we move across, it's 0.08 from here to here. However, we're seeing the radius twice. So X diameter, 1 minus 0.16, 0.84. Z is 0. B is the full diameter of 1 inch. We can check ourselves by adding 2 radiuses back into the previous number. Should be the same. And 0.08 left to right. C is full diameter, and it's 0.5 plus 0.08. Now, another way to show this, put the radius below, move this down, there you go, 0.58. That's what we got here, right? So B in this case would be 0.58 minus 1 radius left to right. So this would be the 0.5 would be the distance here to here. This distance here to here is 0.08 negative. That's the distance from here to here. There you go. Okay, got another part here. This one's laid out in incremental moves. 1 inch here to here, 0.75 here to here, 0.5 here to here. As a general rule of programming, everything's going to be absolute, meaning we have a 0 point and it keeps getting larger. It's not added together like spare change. So I'm actually going to go ahead and I'm going to convert this to make it a little bit easier for me to understand. It's 1 inch here to here, right? Okay. If that's 1 and that's 0.75, here to here, 1.75. Okay, so here to here, 1.75 plus 0.5, 2.25. Everything comes off of the same point. So I did that, I just converted over, added it together, and turned it over to absolute versus incremental moves. So that's A. Length, well, that's 0, right? That's the starting point. My diameter, 0.5. Z, this point here, still 0.5 diameter. 1.0. C, this point here, I moved up to the next diameter, x 0.75, z negative 1.0. Now I'm going to D, 1.75. X, still 0.75. E, looks like I've increased the 1 inch diameter. And I've not moved any left to right, so it's still 1.75. F is the full length of the part. There you go, 1 inch diameter, 2.25 length. Okay, I took the same print, I added a 45-degree chamfer, 0.02, and a 0.02 radius over here. Okay, so remember, this 0.5 is diameter, this 0.75 is diameter, this 1 inch is diameter, right? Because it's this way. Left to right is Z, diameter, which is X, is this. Okay, A is unchanged, B is unchanged, but C changed. So this was 0.5, and then we moved on diameter. Now the base of this chamfer is 0.75 minus 0.02 twice. So 0.75 minus 0.02 minus 0.02, 0.71. So X diameter, well, you put the diameter symbol after it, 0.71. Left to right, it hasn't moved at all. It's still 1 inch. Now, I'm going to move from here to D. D is full diameter. So it's 0.75. However, I moved left to right. I moved from here to here. So now I'm up here. That is 0.02 left to right. So 1 inch plus 0.02, 1.02. So now D, the full diameter, end of that chamfer. Now I'm moving down to point E. I haven't changed my diameter at all. But I've moved left to right. So full length is 1.75 from here to here. However, I have this radius, so I've moved back 0.02. So 1.75 minus 0.02, 1.73. Okay, so for point E, it's 0.75 diameter, right? But how come I went from 1.75? How do I move back 0.02? Well, the distance from here to here is 0.02. So 1.75 minus 0.02 is 1.73. Why didn't I see this twice? Well, left to right, we only see radiuses and chamfers one time. On diameter, we see it here, we see it here. Remember, we're programming this the same way we would measure it. If we measure left to right, we put a caliper here and we measure down here to here. We're touching here, we see this radius one time. But when we measure this way, we would put the caliper here and here, we would see it twice. That's why we're getting this difference. This is a concept a lot of people have a problem understanding, but it's fundamental to what we're doing here. Remember, you measure and you program the same way. We don't cut the part in half and measure here to here. We measure all the way across its diameter. So now, we just finished E, we're going to move to F. So F, full length, 1.75. And that makes sense because I took 1.73 I added the O2 radius, and I got 1.75. So now, I went from 750, I added the radius, and I added the radius. So 0.750 plus 0.02 plus 0.02, 0.79. Let me put the diameter symbol. So now we're going to go up to G. It's 1 inch diameter. And we didn't move any left to right, it stays 1.75. And we get fancy, we could add an H. So x 1.0, z negative 2.25. So that's how you do these points.